Okay, here we are in Derry Camp at the water tower. We are here to challenge a myth that a person could go to the top, dive into a body of water, and survive. What we will need to find out is the height of the water tower. However, we are limited to 3 tools: a protractor, a very strong laser, and everyday math measuring tape that only goes to 150 centimeters. The concept we will be using to solve this is a right-angled isosceles triangle. We try to find the height of the water tower working with a triangle. We have a 90-degree angle here. We are going to use the concept of an isosceles triangle to make sure we have a 45-degree angle here. Okay, here we have a triangle ABC. Side AB is equivalent to the height of the water tower that we're trying to find out. When working with this triangle, we know that angle B here is 90 degrees. What we're looking for is a perfect isosceles triangle where side AB is equivalent to side CB. To make sure we have an isosceles triangle, we need to make sure that angle A is equivalent to angle C. Now we know from the internal sum of all 3 of these angles that they should equal 180 because it's a triangle. So we subtract the 90 that we already have and we're left with 90 degrees. To make sure angle A and angle C are equivalent, we're going to divide by 2 and we get 45 degrees. So once we have angle C at 45 degrees, we will know that AB will equal side CB. So if I move the protractor with the laser until I make sure that the laser hits the top of the tower at a 45-degree angle, and I measure the distance from C to B, I will have the height of side AB, which will be height of the water tower. The next step will be to make sure that I have the laser pointed at a 45-degree angle. To do that, I'm going to put it right directly on the protractor between 40 and 50. Make sure that I have it lined up with the center of the protractor. And there I have a 45-degree angle. So I have the laser attached to the protractor at a 45-degree angle. Now I'm going to turn it on to make sure that we can see it in broad daylight. And as you can see, it will work just fine. So here we are going to measure my pace. The measuring tape is on the ground. We're going to measure the pace so we'll be able to measure the full distance from the protractor to the water tower. So I take a normal step. And it is about 75 centimeters. Now that I have the protractor in place at 45 degrees, I'm going to pace from the tower to the protractor, counting my paces as I go. 35, 40 paces from the tower to the protractor. Okay, so we paced out, and one of my paces was 75 centimeters. And then how many paces to the protractor was 40. So 75 times 40 is 3,000. So it's 3,000 centimeters from the protractor to the water tower. We want to find out how many meters that is, so we're going to take our 3,000 centimeters, divide that by 100, cross off the 2 zeros, and we end up with 30 meters. So the total distance is 30 meters long. Okay, so here we have the 2 sides of the triangle. It's an isosceles triangle. We have the triangle, the angle of the ground and the water tower, which is 90 degrees. And we've determined that the other angles need to be 45 degrees to make the isosceles triangle. We measured the length on the ground to 30 meters. Thus, following the concept of isosceles triangles, the other side will be 30 meters as well. So that means the height of the water tower is 30 meters tall.
Alright, the original myth that we worked with was that somebody could dive off the top of the Dury Water Tower into a body of water and survive. Well, so far, we've seen on YouTube that somebody has jumped from a height that's more than 50 meters into a body of water and survived. Based on our calculations, we know that the Dury Water Tower is only 30 meters. Therefore, the height that you can jump from and survive is greater than the height of the Dury Water Tower, which means this myth has been confirmed.